The real zeros of polynomials. The first theorem that we're going to talk about is called the remainder theorem. If a polynomial is divided by x minus c, then the remainder is the same as example 1 here. We use the remainder theorem to find the remainder. We're dividing 2x cubed minus 3x squared plus x by x minus 1. Our value. So when we plug in f of 1, plus 1 squared plus 1, giving us 2 minus 3 plus 1, 0. Alright, the next theorem is called the factor theorem. For a polynomial function, x plus c is a zero of a function if x factor x plus c. Example 2, the factor whether the function is the factor of the second x plus 2 is the factor of 4x squared minus 3x 7. There are two values, negative 2 f gives us 4 times 10 to the 6 plus 9 times 10 to the 6 squared minus 3 times 10 to the 6 minus 7. When you simplify this out, you get a remainder of 3, meaning that x plus 2 is not a factor of the polynomial. So our answer to this question is no. The next example, x minus 1, is that a factor of x cubed minus x squared plus x minus 1? We're going to find f of 1 is the value of 1. So when we plug it in, we get 1 to the third minus 1 squared plus 1. Simplified out equals 0, meaning that x minus 1 is a factor of the polynomial, giving us the answer of yes. The next theorem is called the rational zeros theorem. Let f of x be a polynomial function with integral coefficients. The only possible rational zeros of f of x are p over 2, where p is the divisor of the constant, q is the divisor of the integral. Remember that this theorem only gives you the possible rational zeros. In example 1, you are given the function f of x equals 5x squared minus 10 times negative 10. Please note that there are 3 roots total because our 3 of our polynomial is 10. That's just how many roots there are. It does not mean how many rational. In A, you are asked to find all possible values of p. Remember that p is the divisors of the constant term. In this case, giving us possible values of p as positive negative 1, positive positive 10. In B, it says find all possible values of q. Remember that q is the divisor of the leading coefficient. In our case, so our possible values are positive or negative 1, positive or negative 2, and positive or negative 6. In C here, it says list all the possible rational roots p over q. The easiest way to do this is to list your p's over your q's, and we're going to go ahead and take 1 and put it over top of all of our possible. Then we're going to go to our next p value of 2. 2 over 1 is 2. 2 over 2 is 1, which we already have listed, so we're not going to list that again. Then we have 2 over 2 and 2 over 6, which is a third again. Next, we're going to go to 5. 5 over 1 is 5. 5 over 2, 5 over 3, and 5 over 6. And then we have to do the 10. We have 10 over 1, which is 10. 10 over 2 is 5. We already have that value. We don't list it again. Then we have 10 over 3. And 10 over 6 is 5/3, which we already have. Please note that we listed all the positive values first, and then we're going to list all the negative values next, keeping them separate. You could be asked how many total possible rational roots there are. in this example, in E, it says using the graph from part D to so we're going to do this by using synthetic division. We'll start with x equals 1. We're going to divide 1 into polynomial. Okay. So with synthetic division, we're going to list all our coefficients, 6, 5, negative 21, and 10. Add the 5 and 6 together to get 11. Multiply again. 1 times 11 is 11. And then add straight down. Negative 20 is 11. 1 times negative 10 is negative 10. Add straight down and we get 0. This is good because we already know that 1's a root, but it also verifies how the break. When we do our next group, negative 5 and 2, we're going to use the answer, this part here, in the top row of our next. Notice that I did left the 0 remainder off. We have 6, 11, negative 10. When we do synthetic division again, we get our answer of the remainder of 0, and we're left with 6 minus 4. That means that 6x minus 4 is if we set it equal to 0, we can get our third root. All right, so in factored form, our answer would be f of x equals x minus 1 times 2x plus 5 times 3x. This is how you would write the polynomial given in factored form if you were asked. Next, we're going to talk about upper and lower bounds. Please note that this is a different definition referring to upper and lower bounds of polynomials. So basically, if you have some graph of a polynomial and you have various roots on it, there's a thing called this a and this b value here. A would be considered your lower bound, and b would be considered your upper bound for all real zeros of x. Basically, we use this to narrow our search for real zeros. The upper bound test for real zeros. If we let f be a polynomial function of degree n greater than or equal to 1 with a positive leading coefficient, suppose f of x divided by x minus k. If k is greater than or equal to 0, then every number in the last line is non-negative, and k is an upper bound for all real zeros of x. If k is less than or equal to 0, and the number in the last row alternates non-negative and non-positive, k is the lower bound for all real zeros of x. For example, prove that all real zeros of f of x x plus 14x plus 8 must lie in interval between negative 2 and 5. So basically, we're saying, is negative 2 a lower bound, and is 5 an upper bound? To do so, we're going to set up synthetic division. So we're going to list our coefficients in the top row. We have 2, negative 7, negative 8, 14, and 8. When you work through the synthetic division, I apologize for my digressions here, you get negative 11, 13, since negative 2 is less than 2, and the last row is alternating non-positive and non-negative. Therefore, these three dots mean therefore, negative 2 is a lower bound. In a similar fashion, I would like you to try the upper bound test now. All right. We're going to use this previous example to find all the real zeros of the function f of x. Again, that function equals 2x to the fourth minus 7x minus 8x squared plus 14x plus 8. In step 1, it says list all the possible roots. All right, so our possible p-values are positive or negative 1, positive or negative 2, positive. Now, down here below, I've listed all the possible factors. Notice that there are only 10 in this case. Also, I've crossed out 8 because in the previous example, we found that the upper bound was 5. 8 is more than 5. 8 is not a factor. I also crossed out negative 4 and negative 8 because our lower bound is negative 2. Therefore, since negative 4 and negative 8 are less than negative 2, they cannot. All right. At this point, we're going to go on to step 2 where it says do synthetic division to find the remaining rational. This could be trial and error. All right, so we're going to go ahead and we'll start with 1 as our first value. So if we start with 1, we set up our synthetic division. And you just quickly go through this. And you see that 1 is not a root. So if we have a remainder of 9, 1 is not going to work. All right, let's go on to 9. Again, 2 does not work, so we'll go on to the next one. Let's try 4. Since 4 gives us a when we use 4, we get a remainder of 0. That means that 4 is a root of this polynomial. Circle it so that we know that 4 is a root. Then we are going to continue on because we still don't have it small enough where we can actually All right, let's try, you could actually keep going in order, but for time, I'm going to go ahead and go with negative 1. Multiply throughout, we get negative 1, which gives us 0. 0. Add straight down, negative 4, which gives us a positive 2. And this means that x squared negative 1/2 is a root as well. Notice that we have 2 rational roots. What's left over in our polynomial is 2x squared, 2x squared minus 1. All right. All right. This polynomial here is something that we know how to factor. So we can go ahead and adding 4 to both sides. Divide by 2, so x squared equals 2. And then we'll square root this. So we get x equals positive or negative. Remember that this is positive or negative. So in this case, these are 2 irrational roots. So we actually answered step 3 here. So we have 2 rational roots, irrational. Now to write our final answer, we are going to simply write it out. F of x equals x minus 4, 2x plus 1, x minus square root of 2, and x plus, the square root of 2. All right, so this would be our answer.